All right, guys, good morning. I wanted to take a moment and give you guys a little bit of feedback and support on the exploring regressions task. So, this is the task that we were working through yesterday in class, but I know we got through kind of the first half of it at the end of class, and sometimes we're starting to feel a little bit brain dead by that point. And then, then I'd asked you guys to try and finish up the second half again, following through the steps. If you ran into any issues, this video should be a good resource for you. Okay, so what you'll work on today in class is you can take a look at this video. I'll kind of demonstrate the couple of steps, and then you can try and replicate the same thing on your screen. Right? That way, you can then pause the video and answer the questions. Again, you're going to be responsible for answering. Let's see, one, two, three, four, 5, 6, 7 questions. Again, everything that's bolded here on this document is what you're going to need to respond to in sentence form on your sheet of paper for the assignment. Okay, so again, the parts that we did yesterday was this portion up here. So I'll quickly review it. We'll go through the first kind of block of these actions, and then I'll give you a moment to pause the video and respond to these first couple of questions. So notice our first step is to click on the triangle next to Gilbert data. Right? And all that shows is that shows the actual data we were working with yesterday entered into a table, and it defines that X is years since 1970. Then our second says click on the circle next to Gilbert data. So here in Desmos, anytime that you click on the circle next to something, it's going to actually make it visible over here. So by having it unclicked initially, it was created, but it wasn't plotted. So clicking on it will now show this. Okay, and then click on the circle next to Gilbert movable line. So if I scroll down, again, click on only the circle. I don't need to worry about opening that triangle or opening that folder just because it's got a lot of the calculation stuff that I needed to create that movable line in there. Um, but what you guys did at this point was you then clicked on these two red dots to try and adjust this line to make that line go through what you thought would be the center of the data. Okay, and again, I left that description relatively vague because here in the next step, we're actually going to look at getting the line that actually goes through the center of the data. So take a moment, if you haven't already, and move this line around so it looks like it would go through around the center of the data. Okay, so I'm just going to leave mine right there. Pause the video if you need to get yours set where you'd like it. All right, that would give you enough to discuss questions 1 and 2. So if you haven't already, please make sure that you can, again, pause the video and answer questions 1 and 2. Once questions 1 and 2 are done, we're going to use this software to actually create the best regression line. The regression line is the line that actually goes through the mathematical center of this data. Now, on Friday, we're going to start to take a look at how can we tell that something goes through the center, because it's not like there's a clear middle between these. So there is a process that we can go through, and I'll show you that on Friday. But I wanted to give you an opportunity to see what the result of this was before we worry about those logistics. Okay, so what we're going to do to get this regression line, which is the best line that goes through the center, is we're going to type in this syntax, the y1 tilde mx1 plus b. Notice the x1 and the y1, those are important because our table has x1 and y1. Okay, so that's where we just need to make sure that we're being consistent with our data. So if I do y1, so if I just type the letter y and then immediately type the number 1, Desmos will make it that subscript form. Now, the tilde is just above the tab key over on the left side, and then mx1 plus b. So that green line there is the line that goes through the center of the data, that's actually calculated and created to go through the center of the data. And again, on Friday, we'll talk about the math behind how that's created and how that's confirmed. So Questions 3 and 4 ask you to compare how close your predicted line was to this, because part of our goal here is we want to just get some idea of visually what does the center of the data look like, right? And then you're also asked to write down the equation of the regression line. The equation of the regression line is actually really easy. Again, that's this green one that we just calculated. Notice down here where it says m equals and here where it says b equals. Those would be the pieces that we would need to write the equation. So the equation of our line here, and please be careful, I can't write this here on the screen, but it would be y equals, and in the place of the m, you would plug in this number, 4590.24. In the place of the b, you'd plug in this number, the negative 27153.5. Okay, so when we actually write the equation of the regression, we don't write the ones anymore. We would just write y and x, and we would also put an equal sign. So the tilde and these ones are just part of the syntax on how do we use Desmos. Okay, so your equation for the regression line should read y equals 4590.24x plus negative 27153.5. Okay. And that was more or less where we stopped yesterday. So if you needed to, you could take a moment, make sure that you've responded to those 4 questions, and then we will take a look at adding on the same sort of information for Tempe. So if I scroll down here, this is going to again walk us through how we can basically hide everything that we've created here, because this is all Gilbert related, and we'll show everything that we want for Tempe. So we're going to click on the triangle next to the Gilbert data. We're going to click on the circle next to the Gilbert data to hide those points. So if I come up here, again, the triangle so I don't see it, and I'm also going to click on the circle. Additionally, for the moment, I also want to hide the Gilbert movable line and my regression line. So notice by clicking on those circles, I'm not deleting anything, I'm just making them so they don't show up. That's really useful here. Okay. Now let's start to show our Tempe data. So click on the triangle next to Tempe, circle, and then the Tempe movable line. So again, triangle next to Tempe, the circle next to Tempe data. Again, that way we can see it all over here. And then if we scroll down, we also want to click on this circle to see the Tempe movable line. I want to show you something important here, that if you come over here into the window and you happen to zoom around or pan around and you're not seeing all of the data quite as well as you were initially, there is a nice trick. Notice right over here by the data, we've got this little magnifying glass. This is what's called zoom fit. You can see how it pops up like that. If you click on zoom fit, Desmos will automatically zoom in to make sure that we can see just that data well. So make sure that if you scroll around, you can either just refresh the page, but then you have to kind of restart, or you can click on that zoom fit and it'll re-zoom in for you. Okay, so pause the video. Again, try and move this line around to see if you can shoot for the center of the data. So kind of like the earlier task, the exact same explanation, but hopefully you saw an example of what the mathematical center line looked like. So we can hopefully get this one a little bit closer. All right. Now, what we're going to do is we're going to get a new center line, a new linear regression that would describe Tempe. And the way that we'll do that is we'll type in this syntax right here. So notice how structurally similar this is to what we had in the first place. The only real difference is instead of y1 and x1, now we'll have y2 and x2. The reason we have those twos is because our data for Tempe has x2s and y2s listed. Okay, so again, if I come in, I type y and immediately type the number 2, it'll make the subscript tilde mx2 plus b. Okay, so now my linear regression line, the line that's actually calculated to go through that idea of center, is in purple. Okay, now if you take a look, you can respond to these few questions. Or here, let's hide our Tempe movable line. Excuse me. So if I go in here, I click on the circle next to Tempe movable line, and if I come up here and I click on the circle next to my Gilbert line, notice now I can see in purple is the Tempe regression line, and green is the Gilbert regression line. Now we're in a position that we can start to look at these three questions. But what these lines tell us about the populations, how can you determine from these lines where the populations would be the same, right? And how similar is this to our initial predictions? So yesterday when we were going through these, people who made their predictions based on just the last 2 years of the data said that they assumed that the populations would be equal in about 2004, 2003 to 2004. Um, People who made their predictions based on an average rate of change of all of the data often were thinking 2007 to 2008 range. And of course, predictions we know aren't always perfect. So there wasn't like a right or wrong answer necessarily here. Right? We're predicting the future. We can't do so with absolute confidence. Right? I want you to take a look at your graph here and again see if we can determine based on this about when would we expect to see the two populations being equal. Remember, the outputs here on the vertical axis are population. The inputs here on the horizontal axis would be years since 1970. Okay, so this is the part that you'll want to finish up. And once you have all 7 of those questions responded to on a sheet of paper, that's what you'll be able to hand in. And then you'll be ready to move on to the practice task for today, which is the task that follows this one immediately.